This is Sound Technology. How does it work?
Let's go! That was lit. Whoa, little mask lines.
On this episode of Sound Technology, How does it work? We'll be looking at headphone impedance and wireless microphones. How do they work? What's their intended uses? Why are they used over other pieces of equipment? First, beginning with some context of what sound is, I'll be moving on to the wireless microphones, and then headphone impedance. What's the sound?
This reminds me of those YouTube channels who do like internet history documentaries. They talk about stories from...
Being a project based on sound technology, there is an important place to begin and understand. What exactly is sound? The noun sound defines the stimulation of hearing organs as a result of vibrations transmitted through a medium. Sound can be referred to as many things, like noise, when the sound is loud and may be unpleasant like traffic. Notes, the sound created by musical instruments. Music, multiple notes played in sequence. What all of these have in common is how sound is formed and heard by the ear. When a sound's formed, it produces a vibration, a movement backwards and forwards.
Was that some voiceover I just heard?
What all of these have in common is how sound is formed and heard by the ear. When a sound's formed, it produces a vibration, a movement backwards and forwards quickly and repetitively. The air is filled with lots of invisible particles that when a vibration hits, carry the vibration until it hits another particles and another, continuing the vibration through many particles like dominoes or marbles. A vibration's movement is called a wave. When the sound waves reach the ear, it passes through the ear canal before meeting the eardrum, which vibrates, continuing the journey of the waves through different parts of the ear. Like the cochlea, this part of the ear is a long swirl of tissue for a larger surface area, with the inner layer covered in little hairs. These little hairs convert the sound waves into electrical impulses. Those electrical impulses then pass through the auditory and facial nerve before being sent to the brain for processing. This is where the brain depicts what the sound sounded like. Fun fact, this process takes less than a tenth of a second, with sound waves travelling at 343 meters per second through the air, quicker through solids and liquids, as the molecular structure includes more particles close together in these states of matter. Waves are formed when a medium is disturbed. Disturbing the medium generates vibrations, or oscillations, which are either perpendicular or horizontal to the wave's motion. When the oscillations are perpendicular to the wave's motion, the wave is transverse. When the oscillations are parallel to the wave's motion, a wave is longitudinal. But what does this mean? Well, when an oscillation is perpendicular to the wave's motion, a transverse wave, particles are being moved up and down, whilst also horizontally. An example of this can be moving a pen up and down, and continuing this motion whilst moving horizontally, creating more crests and troughs.
Did you do that animation? Was that you? Was that big man still drawing? That's pretty good.
Also known as a wave. When oscillations are parallel to the wave's motion, the particles are moving backwards and forwards as it all moves back and forth. An example of this is having a spring and pulling it back and forth.
You just ruined a perfectly good spring.
It is being stretched and compressed whilst moving with your hands.
You can't compress that spring anymore though, because spring extinction.
This information becomes incredibly important when exploring different types of microphones and how you can hear with headphones. Wireless technology. Before you can listen to audio using headphones, it needs to be converted from its original form, sound waves, to electrical impulses, so it can travel through the circuit. This is done using a microphone. A microphone can be wired or wireless. I'm going to be specifically looking at a dynamic wireless microphone. However, how sound is picked up is the same whichever way. When a sound wave hits the diaphragm of a dynamic microphone, it moves back and forth, moving a coil of copper wire which is wrapped around a piece of metal. As the coil of wire moves back and forth, it moves in and out of its magnetic field, creating an electrical signal. How is this transmitted through the air?
RF signal, baby.
Wireless microphones have a special piece of hardware at the end, called a transmitter, which converts these electrical signals to radio waves. Radio waves...
Is it radio waves? Is it radio frequency waves?
Travel through the air, through vibrations of particles, until they arrive at the receiver. The receiver then converts...
Did you do that animation?
I did them all. converts the radio waves back
I like the wiggly wires.
to electrical impulses.
Or are they the RF? Are they RF lines?
It will be.
That's kind of...
Before completing the circuit by arriving at either a mixing console or other output device. Signal, however, doesn't reach infinite distances. To make the radio waves move longer distances, antennas can be connected to the receiver. Radio frequencies, part of the radio spectrum, are all registered through Ofcom. This means that you must buy different frequencies, with any between 446.0 and 446.2 MHz being free to use. Different frequencies and different bands, from VLF, very low frequencies, to EHF, extremely high frequencies, have different wavelengths. The longer the wavelength, the lower the frequency. I did an investigation to see how different amounts of antennas can change the distance of a signal. The radio waves can be transmitted. Investigation 1. No antenna needed.
Okay, from here.
It's me!
1, 2, 3, 4, 5, 6, 7, 8.
It's gone already. It started going out at 6, 7 steps, and then was gone by 8. Investigation 2. Maybe one antenna.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35.
Investigation 3. All the
All the
antennas.
antennas? That's crazy banana.
Test number 3 with 2 antennas, both in A and B.
Well, it's going to go further. They should reach like 20 meters. Because it's for festivals.
You can see it flicking through the...
Walking. Right. I'm going to the drop here at 32 meters.
Experiment entailed using the Sennheiser E8.
But, you know the antennas? Were they pointed in his direction? I think if you point them in his direction, of where he walks through down that hallway, it will increase the distance. Yeah.
05 and XS wireless system, with 2, 1 or no additional antennas added. The investigation found that when no additional antennas were used, therefore only using the 2 built in, the range wasn't very good, getting approximately 4 meters before completely dropping off. When using one antenna, signal strength could be transmitted further, reaching almost 15 meters before dropping out. When using 2 antennas, similar range was established to the one antenna, having a backup signal or more signal moving in another direction, depending on where the antenna is pointing. Having another antenna directed in a different direction shows how important receiver placement is. Wireless receiver placement. When choosing a location of the wireless receiver, you need to first consider how many walls are around the stage, or other location. As established previously, walls block radio waves. You're going to want to choose a location close to the microphone without walls dividing the transmitter and receiver. A good place would be the side of the stage,
True.
so that it's close enough to get a strong signal, whilst not being visible by the audience. Benefit of wireless microphones over wired is the need for no wires between the microphone and the receiver. However, the disadvantage would be the range of the signal and any interferences.
You could say that the disadvantage of distance with wireless is the same with wired, because you can only have X amount of XLR, right? And you're not gonna have like 100 meters of XLR, because then the signal's gonna get weird anyways, isn't it? Because
But it can still be stronger than signal at all. That would be-
Yeah, but if you have like a wireless microphone with like 2-3 antennas, which is what gives you the, you usually have like 2-3 Sony antennas, it should be fine.
Such as walls and other radio frequency devices.
Did you try him walking without his phone? Because I know phones can mess up with RF. Because they can with RF pad. Okay.
Example of this would be 4 or 5G signals for your phone.
Oh, you just
Headphone impedance. When listening to audio, there are 3 options. Whether you choose the active or passive speakers, headphones, or even earphones. However, the options can come with a limitation or benefit depending on how you see it. They all have a headphone impedance. Headphone impedance is the measure of electrical resistance to the audio signal passing through the headphone drivers. Resistance in a circuit is the measurement of how difficult it is for a current of electrons to flow. So what all of this means is that the impedance is how much resistance occurs to the audio signal on its journey through the headphones. Measured in ohms, this is typically ranged between 8 and 600, with 32 ohms being the standard and the most common. Headphones are built to convert an electrical signal to sound waves. Headphone drivers receive a signal which passes through a coil of wire. The number of windings and thickness of the cable determines the impedance. A higher impedance means the more windings of the coil or thicker wire to travel through, which needs more voltage or power. A lower impedance means less windings of the coil or thinner wire to travel through, requiring less power. However, this does mean that it is prone to blowouts due to the overpowering.
Ooh, I
They are
didn't think about
compatible
the
with a wide
blowouts.
variety of equipment. though.
True.
Higher impedance headphones often require additional hardware, like amps, to meet the power demand, making them not as useful for live sound engineering, because most mixing consoles have a lower impedance output, but better for recording and mastering in studios. I'm going to be investigating how a lack of power, the demand of impedance doesn't meet the requirement of impedance, can change the sound of outputted headphones. The equipment.
The equipment.
For this experiment, I am using the Beyerdynamic DT770 Pros
Yo,
32 ohm
I'm on my
edition,
head right now.
which are closed back, which just means that the back is solid plastic, and the Beyerdynamic DT990 Pros 250 ohms edition, the limited edition black edition,
Limited edition, black edition. Wow, you have spent some money on that.
which is open back, which means that the back of the headphones has gaps, which causes slight bleeding of noise, but often sounds slightly more realistic as it has a more natural sound pressure level, or
True.
SPL, for the 2 comparable headphones. This is the Focusrite Scarlett 2i2, set up with my Shure SM7B and quarter jack to 3.5mm converter, ready for the headphones. As the standard, the output volume has been set to about 1 o'clock. Sound change? 770s, the 32mm headphones.
Wow, it sounds just like my tinnitus.
$990 Pros, the 250 ohm headphones.
I prefer the first one. The first one.
Now we're going to try again with an additional amp that can now output 250 ohms. We can try first with the 770s. Wow. That is very loud.
True, it is very
I
loud.
could hear the noise bleed from them before I'd even put them on, and these are closed back. Now we're going to continue the test with the 990s with the 250 ohm headphones.
It's loud, isn't it?
Sweep the frequencies!
Sweep the frequencies!
So now, we're going to try both of the headphones again, but with a full frequency sweep to see if any of the frequencies change now there's a different impedance. the 770s.
Jeez, that vibrated my skull.
$990s.
It dropped off maybe around 17.5, 18k.
Yeah, the first one was worse. It was
After this
worse.
investigation, I can see that the
That's why Pete had to leave the room. You put up such a high frequency that you vibrated his skull and caused him to have a nosebleed.
32 ohms headphones are a bit louder than the 250 ohms headphones.
Yeah.
This is because the amp doesn't quite meet the required power to drive the drivers of the headphones. However,
True.
when using
That's
the
how it
additional
works.
headphone amp capable of up to 250 ohms, the sound is quite similar, only difference being the amount of noise bleed due to the fact a pair of headphones was closed back and one was open. So overall, the findings of this investigation match up with what other people have found doing their investigations of the same type.